In today's episode of KubeFM, we got a chance to speak to John Howard, who's a senior architect at Solo.io. We talked about Kubernetes security, service mesh, and workload encryption. John explains the evolution of Istio, the role of Mutual TLS, or mTLS, in securing cluster traffic, and the trade-offs between DIY security implementations and service mesh solutions. We also discuss Ambient Mesh, its impact on simplifying encryption, and how it compares to Cilium's network encryption approach. John provides insights into the challenges of scaling security across Kubernetes environments, the complexities of implementing identity-based network policies, and how emerging standards like Network Policy version 2.0 aim to improve security. We also examine the performance implications of different encryption methods, such as WireGuard, IPsec, and TLS, as well as their impact on Kubernetes networking. Finally, John shares his perspective on the future of service mesh adoption and the evolving role of security automation in cloud-native environments. This episode is sponsored by LearnK8s. LearnK8s has provided Kubernetes trainings all over the world since 2017. Courses are instructor-led and are 60% practical and 40% theoretical. Students also have access to the course materials for the rest of their lives. LearnK8s provides trainings both online and in person. For more information, check out learnk8s.io. Now, let's get into the episode. So, John, welcome to KubeFM. Can you tell me really quickly what 3 emerging Kubernetes tools that you're keeping an eye on?
Hey, welcome. Thanks for having me. 3 tools. Maybe an odd one, but I think one of the things I'm looking out most for is not new tools, but is Kubernetes itself and new things happening in that. I often try to think or hope that Kubernetes is the stable, boring thing that is already doing everything I need, and I don't need to worry about what's going on with it anymore. But every release or two, they have something pretty compelling that's always exciting. So, the past ones I can think of, native sidecar support, obviously huge for me, but also like replacements for webhooks. So they have like validating policies, mutating policies. Those have been cool as well. So there's always new stuff that kind of enhances existing use cases there. Some other ones, I would say a project called KindNet, which is kind of this newer CNI. It's basically looking at if we reinvented what Kubernetes networking looks like in 2025, how would we do that? And it's basically checks all the boxes of super simple, but also a lot of features and super high performance, contrasting with some of the other previous implementations that maybe are high performance and have a lot of features, but are super complex. Other ones, I would say I'm usually looking at older projects, not newer ones. So things like something like Prometheus or something that's been around for so many years, and looking through their releases and what issues are they digging into 8 years into the project, and they've got rid of all the low hanging fruit. What's left? And oftentimes they say oh, that issue device that might impact our project too. I actually take a look at that.
All right. Now, for those of our audience that maybe don't know you, can you give us a quick introduction, a bit more about who you are, what you do, and where you work?
I'm John Howard. I am a senior architect at Solo.io. We are a company that works on cloud connectivity. So we do service mesh and API gateways. So I personally spend most of my time working on Istio, which is a CNCF service mesh project that I've been working on for about 6 years now, previously at Google and now at Solo.
Fantastic. And can you tell me a little bit about how you got into cloud native?
Yeah, it was actually somewhat just by chance. I joined Google out of college, and they have a team assignment thing, and I said vaguely I was interested in backend work, and they said, "Here you go. Here's Istio. Have at it." And so that was back when Istio was, I think they just released the 1.0 release. So really exciting time to get involved in the project. It was there, it was solid, had a lot of hype, but there was so much work to be done to make it something that was, where it is today. So pretty interesting thing to just get left into, I thought.
Very good. Now, the Kubernetes ecosystem moves very quickly. You're mentioning previously about, those projects that you're taking a closer look at. How do you stay up to date with all the changes that are happening? What resources work best for you in terms of podcasts, blogs, tutorials, anything of that nature?
Yeah, I'm often, on big projects I already know about. I'm subscribing to them on GitHub to get notifications about the releases. For other things, I mean, you can't keep up with all of them. There's so many. But Hacker News, Reddit, blogs, all those sorts of things. I'm more of a text guy generally, somewhat ironically given that the media here. But I love to, see what people are up to there. So.
And if you could go back and share one career tip with your younger self, what would it be?
Probably forget about cloud native and go work at NVIDIA or something. But more seriously, though, I would say probably just remember it's a long journey. Don't worry about optimizing for getting something done this week or next week and do it poorly. Like every time that I've taken the time to do something that will pan out over a long period of time, it's paid off. But it's often the scary choice to make at the time. So,
all right. As part of our monthly conflict discovery, we found an article that you wrote called "I Just Want TLS on Kubernetes." So the following questions that we're going to be covering are designed to explore these topics further. Let's start with a combination Kubernetes security. Many teams want to secure their cluster traffic, but they're unsure where to start. What's a typical request you hear from Kubernetes users regarding traffic encryption?
Yeah, I mean, they range a lot. Sometimes it's at the far end of they don't really know what they want, and they're asking. They come to us and say, "I need security." Well, what kind of security? I don't know. I just need security, right? I need this. Other times they're on the other end of the spectrum. They have like a 10-page document of the exact semantics of what exactly they need. They need this encryption protocol with these cipher suites, these versions. They need to meet these government compliance checklists, all these different things, and everything in between, really. But ultimately, what they want usually is something along the lines of they want their traffic to be authenticated so that they can write policies against it and achieve kind of what is traditionally called a zero trust network setup. What that means, well, probably different to everyone. What it means to me, at least, is that rather than allowing anyone to connect to anything, at every hop along the way, you're authenticating and authorizing who can actually connect to you. So a single service, if it should only receive traffic from, say, our front end, we would authenticate, say this request is from the front end, and only the front end is allowed to talk to me. And maybe they can't hit like my admin port or something because that's supposed to be, for admin purposes. Things like that. So that's often the goal, the end goal, but along the way, there's a very long path to get there and a very winding path often. And the other end of the goal is just like checklist. Compliance often is checking a box. And so it's, here's the list of boxes and we got to check them off. That's common for government compliance list I found.
Now, in the article, you mentioned specifically mTLS. For those who might not be familiar, can you explain what mTLS is and why it's considered important in Kubernetes environments?
Yeah, so mTLS is Mutual TLS, and TLS is transport layer security. TLS is super common. If you're listening to this, it's probably over TLS. Any website you go to these days is all over HTTPS, which is TLS. And so what Mutual TLS means is we're just adding the reverse layer of authentication there. So when I go to a website like example.com, I'll go to example.com and get a certificate that they present that has their identity, example.com, in the domain. And then I verify that. And I know to trust it because there's a list of trusted CAs that I have in my machine. What Mutual TLS is saying is that as the client, like my browser, I'll also give you a certificate and say like, hey, I'm John, here's my certificate. And then the server can authenticate the client. Now, in like the web world, no one ever does this. Technically, you can do it, but if a pop-up on my browser came up and said, attach your client certificate, when I visited a website, I would run screaming, right? So we've solved for the web authentication at a different layer, doing things like logins and things like that. But it's still a potential option that's useful for the infrastructure layer. So in Kubernetes, for example, what this would mean is that like any workload to workload traffic, not only is the server serving a server certificate, but the client's also presenting one that allows the server to authenticate them. So going back to like what I said in the front end to back end scenario, and we want to authenticate and authorize them, like a front end would actually have its own certificate that it would present to the back end to verify who it was, where it came from.
When it comes to implementing mTLS, some teams might consider a do-it-yourself approach. What does a DIY implementation of mTLS look like in Kubernetes, and what challenges might teams face?
Yeah, it's tricky because on the surface it seems simple. Like anyone that's developing an app can probably figure out how to make it serve TLS instead of plain text. But the details and the reality at broad scale are often far different. So like at a very high level, you'd have to first get all your applications with TLS certificate. This alone can be extremely challenging. There are some great tools in the ecosystem like Cert Manager and Spire that can make this much simpler. But often people are DIYing this as well, which adds even more to the complexity. Then you need to go actually get that certificate to all the applications and update them to use them. Oftentimes when people are trying to meet their requirements, they don't just require one or two applications to have mTLS, they want the entire cluster to have it. So that also includes third-party applications. That includes super legacy stuff that we don't want to touch and update anymore. Everything, right? Then you also need to update all your clients to start using TLS, and they're going to have to start attaching a client certificate as well. You're going to want to ensure that you don't somehow have an outage between these steps, because if I'm serving TLS, now I'm not serving plain text, right? So how do I manage that transition across the entire cluster, maybe even across the entire company of, hundreds of thousands of workloads? That can be extremely challenging. Let's see, I don't want to go, there's a huge list. I'll cover a few more, but it's a ever-growing list you'll find, which is part of the problem. You'll probably also want to make sure that you've implemented, for example, certificate rotation properly. It's kind of the worst outage to have, that a timer just goes off at, say, midnight or something, and suddenly you have an outage across all your environment because you forgot to rotate all your certificates that were, humming along fine for 90 days or whatever the lifetime was. And you'll want to, understand what traffic is encrypted, what is not. You'll need to do all this sort of stuff. Outside of Kubernetes, oftentimes what I would see people do is put a reverse proxy in front of their applications, like Nginx or Caddy or something, and say, this will take care of TLS. And they just kind of offload it from their application. But in Kubernetes, that is not as common to do on every single application. And you still have most of these problems anyways. It's actually even more complex than just all this, though, because in standard TLS, you have an intrinsic link between the domain name and the certificate. I go to example.com by DNS, it helps me find where that is, and then it presents a certificate that's example.com. But if I'm an application, I get a request from someone, how do I know who should be able to talk to me? There's no standard linking of a client identity. There's some de facto standards like Spiffy, which is tied to the Spire project I mentioned earlier, that defines a loose scheme for workload identity. But it's not it's just out of the box and automatic. Hey, I know that's front end, and I got this certificate that says front end, right? You have to come up with a naming scheme. Like in Istio, for example, we have a naming scheme that's namespace / a namespace / SA / the service account, which is fine, but we had to come up with that. And then you need to go update all your applications to understand that and all this stuff. So it's just a kind of an ever-growing list of steps we need to take. I don't see this as successful in large organizations.
And given the complexities of the DIY approach, many turn to service mesh solutions. Can you explain what a service mesh is and how it typically implements mTLS in Kubernetes?
Yeah, so I briefly mentioned instead of doing this in your application, putting a reverse proxy in front of the application and offloading the TLS to that. Service mesh is kind of like that, but better, or at least more optimized to this work, this use case. So how I view service mesh is you have all these things you might want to do in your application. We're talking about TLS here, but it could be a whole list of things like observability, logging, metrics, traces, reliability, retries, timeouts, things like service discovery, and not just authentication with mTLS, but the authorization. There's all this stuff. And if I want to go put this into every single one of my applications, it's going to take me a lot of time and effort. If I have a lot of different languages, it's going to just amplify that time and effort. If I have third-party applications, I'm kind of screwed, right? So what Service Mesh does is don't worry about doing all that stuff in your application. Keep the application simple, focus on the business logic. Alongside your application, we'll put a small proxy, and it's going to handle all that for you. All of your traffic in and out of your application will go through this proxy, and you can offload that, and that can be upgraded outside of the application lifecycle. It can be dynamically configured. And so you get a lot more flexibility and simplification in your application. So specifically to mTLS is that it can offload the mTLS as well, and that your applications don't need to change at all to do mTLS because the infrastructure does it at the service mesh layer.
While Ambient Mesh sounds promising, it's not without criticism. One of our podcast guests, William Morgan from Buoyant, has raised some concerns about this approach. He mentioned the potential single points of failure. For example, restarting a daemon set could affect the networking for several pods, and encapsulation, since now the pod depends on an external cluster.
Yeah, so with service mesh, there's been kind of a few different architectures that have been explored. So the earlier most promising one was the sidecar pattern, which meant that for every single application, like each pod, you would actually have a separate container, we call it the sidecar container, that would run alongside that application. You'd have a one-to-one relation between the application and the sidecar serving the traffic. The kind of newer approach that we've been exploring in Istio that's been GA for about 6 months now is what's called ambient mode, which brings this out of the pod and splits it into 2 layers. One is like this node proxy layer that's handling the L4 and encryption. And another is this waypoint proxy layer, which we won't talk too much about because it's not important to TLS, but it handles all of the other rich feature set. So the idea of this was to reduce the overhead in terms of resource, but also in complexity and operations so that it's more invisible to the users and applications. It's not so tightly coupled to the lifecycle, and also increase the performance and reliability there. So the concerns raised that there are good things to look at for sure. I do think that there's, any software always has trade-offs. I think the trade-offs for most people in ambient mode is quite a benefit, especially like hands down for the use case of I just want mTLS on Kubernetes. So for example, like the reliability concerns about a single point of failure. To some extent, it is true. All traffic flows through one binary now. That is true. And it joins a very long list of single binaries that are required to keep a node functioning in Kubernetes, right? If kubelet goes down, for example, my node is down. If the kernel has a panic, my node is down. If kubeproxy, like the IP tables, all these different systems that are a kind of single point of failure on the node. And that's kind of the way I view reliability on Kubernetes, is that your node is not the thing that needs to be reliable. That's why you have many of them, right? You have a lot of nodes. And it's the aggregation of all the nodes that makes Kubernetes reliable. That's why Kubernetes is designed the way it is, to have these kind of ephemeral nodes. And so, yes, it's true that a node theoretically could go down by one Z-tunnel having an issue. Obviously, we designed the node component to be extremely high availability and reliable, handle things like this well, but things could happen, right? But if it does, the node is down, right? Your cluster is not down. And Service Mesh can also help when certain workloads go down, make sure that we don't send traffic to them or allow us to fail over to other clusters and things like that.
Some CNIs offer network encryption options like IPsec or WireGuard. Why aren't these considered equivalent to TLS for securing Kubernetes traffic?
Yeah, it's an interesting question because oftentimes there's a mixing of the protocol itself and the implementation of the protocols. So if you're looking at something like mTLS, you're often looking at something like a service mesh like Istio or Linkerd. Whereas if you're looking at IPsec or WireGuard, you're looking at something like Cilium or Calico. In general, those IPsec and WireGuard tend to be node-to-node encryption, which is different from workload-to-workload encryption, right? With node-to-node encryption, you don't actually verify the identity of a specific workload. You only have the node information. So it's a less zero trust model in that it's not as finely grained identity. There's also like one just very pragmatic thing. I talked about checklists. Like there's a very common compliance requirement is FIPS, which is needed for a lot of US government use cases. WireGuard is not FIPS compliant and probably never will be. So for a lot of people, that alone just strips it out of the running. IPsec is, or can be at the very least, but often is quite complex. If you're running it in, many of these CNIs, you have to pick between IPsec and a lot of the features they offer. It's not like you just turn on IPsec and everything works fine, right? And some of these are pretty big features. Like I know one of the CNIs, for example, disables their support for the Gateway API, Kubernetes Gateway API, which is kind of one of the bigger exciting projects going on in the ecosystem if you have IPsec. So you're making big compromises here. The other aspect is performance. I think often people make the wrong choice here and look at mTLS and they look at something like WireGuard and they pick WireGuard for performance reasons. Because WireGuard has been kind of heralded as this high performant VPN implementation, it's moved into the kernel natively and I don't know, it was a pretty long time ago now, which increased the performance, and it just looks like it's like the silver bullet, right? It's really not actually the case. Like if you look at benchmarks comparing mTLS to WireGuard and IPsec as well, but I've looked more at WireGuard, so I'll speak to that. You'll see that mTLS performance is actually largely better than WireGuard in most cases, or equal in other cases. Depends what you're looking at in terms of like latency or throughput. So I think there's this weird perception that if something's in the kernel, it automatically makes it faster. We see this a lot with the eDPF discussions around CNIs as well, that just because the code is running in the kernel, it's magically faster. But that's not the case, right? The processor is still doing the same amount of work, whether it's in user space or in the kernel. And TLS, it's not at the kernel, but it's able to do that faster because processors have special hardware optimized for TLS these days. And just at the protocol layer, like it's able to encode or encrypt more information at one time in bigger chunks, which makes it much more efficient, right? So if you do like a benchmark, for example, you'll probably see WireGuard and mTLS have the same latency, but mTLS 3 to 4 times more throughput. That being said, for most people, that doesn't really matter. So if you're picking your encryption mechanism based on performance, make sure you really care, because for the most part, the difference between 2 gigabits per second and 10 gigabits per second is so far from relevant to where organizations are struggling. So,
security in Kubernetes often involves multiple layers. How does mTLS interact with other Kubernetes security features, such as network policies?
Yeah, it's a good question, and one that's being actually explored in the network policy space. There's kind of this newer effort of, I actually don't know what the name is. I'll call it Network Policy 2.0. That's basically evolving network policies and specifically looking, how do we make mTLS more deeply integrated, and not just mTLS, but really any identity, like pod identity based network policies. Because today the answer is they kind of interact, but not in like a nice layered ideal way. So generally, like in service mesh and CNI, they're kind of separate layers. So the CNI would enforce traffic first based on network policies, and then it would hand it off to the service mesh, which would enforce its own layer of policies on top of that. Why does the service mesh do its own? It's because it has more information, right? It has access to the TLS identity, and oftentimes it also has access to HTTP attributes or other higher level protocols on top of TCP. So you can do things like, denied post requests or things like that, or authenticate, a JOT token in an authorization header. So the layering, it's kind of there, but it's not like it's this cleanly layered system where we're just kind of gradually enforcing more and more information. So in ambient mode, for example, that is kind of what we've done. We have 2 layers in ambient mode. We have the node proxy, which is only handling TCP and mTLS. And that operates on, that has 1 layer of identity and authorization. But there's this other component, the waypoint proxy, that can be put in the path and adds another layer of authorization on top of that. That's more service-based, it's more HTTP based, and we kind of have this nice layering. But there is still a bit of an awkward gap of like network policy to service mesh policy and where those lie. Oftentimes in practice, what we see is that users either do a defense in depth strategy where they enforce both. Often actually they just do one or the other. But if they're doing both, they're doing either defense in depth where they enforce kind of the similar policy of both layers, or they're using network policy as a very coarse-grained tool and then service mesh for the fine-grained tools. So just doing things like maybe this application can't talk to the internet, for example, something very broad like that. Or, this namespace can talk to this namespace, but then within that, at the service mesh layer, we say, no, this identity, this specific workload can talk to this specific workload on this port with this path, things like that.
And As Kubernetes and cloud-native technologies evolve, so do security practices. What emerging trends or technologies do you see in the realm of mTLS and Kubernetes security?
Yeah, the big thing I found over the years is that it's not so much about the features in security; it's about getting people to use it. So the biggest issue we had for many years with Istio is I listed all the things you can do with it, and it's like there's a laundry list of features. I only covered the surface. If anyone goes and adopts a fraction of the features, they will have achieved an incredible amount of value. But the problem is, it can take a lot of effort to do that, right? It takes a decent amount of effort to even just get feature one, and then each incremental feature is, a bit of cost. And so the problem that we saw again and again was people coming to us and saying, "Look, I just want mTLS." This is like the title of the blog post. "I just want mTLS and Kubernetes." And tell them, "We have this great tool. It's Service Mesh. We'll give you all this value, and buried in that value is mTLS as well. You'll pay the cost of all of it, even if you just want mTLS." And so what we did, and this is the origin story for Ambient Mesh, was so what would it look like if we just served the mTLS use case and we optimized for that, and we just made it dead simple to get mTLS. And then once you have that, you can use that as a stepping stone to get the rest of Service Mesh. And so that's how we came up with ambient mode, where hyper focused on just the simplistic use case of mTLS, get that everywhere. So one of the key goals, for example, was low footprint, compatibility. So that we don't modify any traffic, we don't break any traffic. We should be able to work anywhere with any application. Rolled out cluster wide without fear of application behavior changing, which was a common issue with Service Mesh, because we were injecting these great features like HTTP load balancing, which is usually good, but sometimes changing things even for the better is breaking applications because they expect certain things, right? So by default, we don't do that. We don't modify traffic. And that's kind of the way to get security, I find, is that you just need to get it everywhere. That's really step one. And most people aren't at that phase. Once you get things there, then you can start playing with the fancy features, like what kind of fancy authorization policies are we doing? Maybe I have some crazy AI analysis tool that's telling me like this is an anomaly, things like that. But you can't do the fancy things when you don't have the baseline, and most users don't have that yet. So that's kind of where I think it's the main focus.
And we've covered a lot of ground regarding mTLS and Kubernetes. Given all these options and considerations, what would you recommend for teams looking to implement mTLS in their environments?
Yeah, I think in general, like the DIY approach is problematic if you're not really aware of all of the things it involves and have a clear vision of what it looks like to go from the start to the end and how to get there. For most users, I would not recommend it. I can't recall many or any cases where I've seen that successful in a large organization. In general, like Service Mesh is the way to go. I think ambient mode in particular, especially if you just want mTLS, like I said, like it was literally the case it was designed for. And I think if you look at like what would be the ideal way to get mTLS everywhere in Kubernetes, ignoring everything else, what Ambient Mesh has is exactly what you'd come up with. And so to me, that's the obvious choice. If you're already on an existing Service Mesh, Istio with sidecars or other Service Meshes, obviously that's also fine. You already have mTLS probably, so you don't need to go make changes to get mTLS. You can start using it today. But in general, I would recommend kind of in that order, like Ambient Mesh, traditional sidecar mesh, and then DIY as kind of the last resort. Yeah, I mean, it's somewhere in there. There's probably also like the CNI encryption layers, but it's not mTLS, which I think was the question. So that's a more complicated answer.
When you're not working with mTLS, Service Mesh, Kubernetes, what do you like to do in your free time?
Yeah, I'm into cooking. Like to switch up what I'm going through. Sometimes pizza, sometimes ice cream. Always varies. So
Very good. What's next for you?
that's a great question. For now, more Service Mesh. Where we've got ambient to GA in the Istio went at 24 about 3 months ago. But as I found, that's only the beginning. And now it's about seeing it go into production with real users, see what feedback they have, and just continue to iterate and trying to get this thing everywhere. everywhere that should be anyhow. So I'm excited to continue on that. It's been a lot of fun since I joined Solo about not even a year now, but we've been moving really quick. So I've been enjoying that.
And how can people get in touch with you?
Yeah, definitely. I'm on all the Slacks. Howard John is my name on everything. So I'm on the Kubernetes, Istio, CNCF Slacks, GitHub, LinkedIn, Blue Sky, Apple Blog, which of course is about. So I write about Go, Kubernetes, Istio, Service Mesh, things like that there. Yeah, anywhere really.
Fantastic. Well, John, thank you very much for joining us in KubeFM. Look forward to speaking to you soon. Take care.
Yeah, thank you. See you.
Have a good one. Cheers.